Thank you all for getting up this morning to get started. Another great day. I want to pick up on a few of the points that Ed had made during our presentation. This reflects some of the research that we've done at the McKinsey Global Institute, which is McKinsey & Company's research arm on big data. And, I think a lot of people in this room are familiar with the fact that a number of different groups have looked at how much data is being created, how much data is being generated, stored, et cetera. And I'll have a few charts that look a little bit like Ed's, these hockey stick type charts. But really what we focused on was how big data can create value for organizations, for companies, for the public sector, as well as for individuals. So I'll just run through some of those research findings. It's all documented in an embarrassingly large report, about 150 pages, but if you just read the executive summary, you'll get most of the key points, so we made sure that that was possible. But just to take a look at some of the key findings. First of all, clearly the amount of data that organizations and individuals have available to them is exploding. That's a result of a number of different trends, some of them technology, some of them adoption. But it is creating new ways to create value, new innovations. And in fact, indeed, we do believe that it's going to change the basis of competition, that the use of big data is going to be a key basis of competition for companies, for sectors, and indeed for economies. And that's quite a strong statement. And then finally, of course, there are a number of different enablers or challenges that need to be addressed in order to capture some of that value. So just diving right into it. It's no surprise to anyone in this room probably that the amount of data that is being generated is exploding. But if you actually look at the types of data which exist, it's only been about a quarter century, and the percentage of data that is in analog versus digital form has completely transformed. And that changes what we can do with data, obviously. And why is that? Well, there are a number of different reasons. We have both our traditional transactional databases are exploding in size, but we also have new forms of data, so people are probably familiar. Social data is exploding. Multimedia, if you look at any of those stacked column charts around what types of data are carried on internet backbones, if anything that has video, again, it completely swamps everything else to a certain extent, right? So a lot more bits are being generated. But then before we did this research, I think some people would have said, well, big data, it's sort of a big deal, but maybe it only matters in a few industries, right? So maybe it only matters in financial services, because in financial services, the data center is the factory. So, okay, I get there's probably a lot of data there. Or maybe in a lot of consumer-facing industries, because if you look at all of the data that's generated by consumers, okay, so then I can understand why there'd be a lot of data available there. But when we did the research, and this is data from the United States, similar patterns are found elsewhere, and looked at the average amount of data that's available to a company with over 1,000 employees. In fact, for 15 out of 17 sectors in the U.S. economy, you have the average company with more than 1,000 employees has more data than the U.S. Library of Congress. And also for, again, for most of those industries, the average company has more data than Walmart's data warehouse from just a few years ago. In other words, big data matters in pretty much every sector of the economy, and in fact in every function as well. So we do think that this is something that has extraordinarily wide-ranging scope. And so, part of what I'm here to do today is just to try to set things up for the rest of the two days that we'll be here. So another thing that comes to mind is, sometimes people think, well, big data, that suggests maybe big business or big government, big brother, right? This idea that, this huge amount of data, maybe all the value is going to accrue primarily to, large institutions, large companies. And I'll hit this point a couple of times today. But in fact, we do find the use of big data. I think there are probably people in the room who are part of the quantified self movement, for instance. Big data can also be an enabler for individuals, and that a tremendous amount of surplus can, in fact, accrue to people who are able to use big data because it's becoming more and more available, becoming more and more accessible. So this is an example from Fitbit. Again, it's a way of looking at both the data that you have yourself and comparing it with large populations. Another point, I mentioned that there are new sources of data which are, new sources which are driving the growth in data. social media, multimedia, et cetera, are transactional databases. But also increasingly we're finding, this is another topic of research for us, the Internet of Things, or the idea of sensors and devices embedded in the physical world, connected by networks to computing resources. In other words, everything from sneakers to aspects of the built environment and physical infrastructure such as bridges, complex manufactured items such as jet engines, all of these devices now are increasingly providing us with data from the physical world. People are probably familiar with this idea of exhaust data that's collected for one purpose and potentially could be used for another, right? You drive your car, exhaust comes out of the back of your car. You drive a business or an organization, you get data exhaust as well. You drive a physical object, and if it has sensors in it, data also appears. And the amount of this type of data is, again, increasing by leaps and bounds across a whole variety of different sectors. Everything from home appliances, security applications, transportation and automotive. We're looking at more and more of this data being generated. Not only is the amount of data being generated, but clearly, and this is quite similar to something that Ed showed as well, our ability to compute, our ability to analyze this data is also exploding by leaps and bounds. If you just look at how much computing power actually exists in the world, it is increasing by a tremendous amount, as well as our ability to store it, either in the cloud or not. Now, one interesting fact is, if you look at all the data that's actually being generated and compare that with all of the storage capacity, which is being manufactured, disk drive platters, static RAM, et cetera, in fact, our ability to generate data is greatly outstripping our ability to store it. So we're going to have to throw some of it away, and some of the thoughtful things you might want to do are to try to understand what sort of data you need to keep and what sort of data you're willing to throw away. So with that being said, what really are the implications of this? Well, we're going to hear in a moment with a video from a friend and colleague, Professor Eric Brynjolfsson from the MIT Sloan School, that in fact, the fact that we can measure new things actually changes the competitive dynamics and the ways we can create value.
Most great revolutions in science are preceded by revolutions in measurement. And we have had a revolution in measurement the past few years that have allowed businesses to understand in much more detail what their customers are doing, what their processes are doing, what their employees are doing. And that tremendous improvement in measurement is creating new opportunities to manage things differently. We've done research to look at some of the changes in the attitudes people have to how they make decisions. And we've found a shift from using intuition towards more using data and analytics in making decisions. And this change has been accompanied with a measurable improvement in productivity and other performance measures.
So what he's really speaking to there at the end was the fact that there are new ways to create value, and that in fact big data is going to make a difference there in terms of, as I said, how companies will compete going forward. So what did we do as part of the research? We actually looked in 5 deep dive domains. We would have loved to look at the entire economy, but we didn't have enough resources to do that. We looked at the U.S. healthcare system, complex system, lots of data, many stakeholders. We looked at public sector administration focused in Europe. We looked at the retail sector, primarily in North America, manufacturing globally, and then another domain which wasn't really a sector, but personal location data. This increasing amount of data that we're all generating because we're carrying cell phones and devices that start with a lowercase I, et cetera, et cetera, et cetera. And then try to understand at a fine-grained level how can value be created using the data in each of those domains. And then from all of those deep dives, synthesized 5 ways in which value, we discovered patterns can be created using data. So let me just quickly run over them. First is simply providing transparency, simply providing access to information. It's so, it's so unsurprising and yet quite powerful. For example, if you look at some knowledge worker groups, that up to 25% of their time is taken simply searching for information or data, and then perhaps actually collecting it or running it over in a physical environment, sneakernet as we used to call it in the networking industry. This is an extraordinarily powerful idea, and if you look at the U.S. healthcare sector, for instance, up to 30% of doctors' offices, don't even have data in digital form. We talked about that transformation from analog to digital. Again, that transparency will definitely be lacking if you don't have things that are digitized. And there are wide swaths of the economy where that's not true. Secondly, exposing variability and enabling experimentation. So exposing variability is simply the use of big data in order to understand where there are differences in performance. This has been done before in terms of benchmarking. If you look across multiple call centers, if you look at different manufacturing organizations, if you look at how much teachers enable their students to improve in their educational achievement. Just understanding that there is performance variability and exposing that through big data can often drive a tremendous amount of performance increases. What's interesting about that is you might think, well, human resources theory says, well, let's make sure we pay the people who are doing better with a bonus and maybe punish the others. Oftentimes you don't even need that. Maybe you just combine exposing variability with transparency. Nobody wants to be at the bottom of one of those tables, right? And so that often drives performance just in and of itself. But also the ability to enable experimentation, to treat an organization as a 24/7 laboratory. Clearly, we're starting to see this in a lot of the online companies, which devote a certain number of their web hits to experiments. But we're also seeing this increasingly applied in offline forms. So, for instance, people might be familiar with Gary Loveman, who's the CEO of Caesars Entertainment, formerly the Harrah's Company. And, illustrating this change in the way some leaders are viewing their companies, he says, look, there are two ways to get fired from my company. One is you can steal from my casino, or two is you can fail to have a control group in your experiment. And so really changing the way that organizations make management decisions. Thirdly, segmenting populations. Segmentation is not something new to anyone who's in a consumer-facing industry, and we do think there's tremendous amount of headroom, location-based segmentation, real-time segmentation, micro-segmentation, et cetera. But the other thing that we discovered was there are wide swaths of the economy, again, where this idea of segmentation is almost countercultural to the mindset. So in public sector, people would think, oh, I can't treat my citizens differently, or I can't treat my employees differently, or in utility says all my ratepayers have to be treated the same way. And yet if you actually apply segmentation and treat different populations with the actions that are tailored for their particular characteristics, you can often drive a tremendous amount of efficiency and effectiveness. Fourthly, replacing or supporting human decision-making with automated algorithms. It's probably the most straightforward one for the people in this room. And then fifthly, innovating new business models, products, and services. Oftentimes, for example, you're able to monetize the exhaust data. So, we find a lot of companies and organizations in an intermediary position. You might be a payments provider. You might be a provider of logistics. You might actually be a social networking provider. And one of the ways that you can actually capture value is using a business model that monetizes that exhaust data, monetizes that data that you find yourself, that data stream that you find yourself in the middle of. Now, I mentioned before that we have this assertion that going forward, the use of big data is going to be a key basis of competition. Here's a very simple analysis which just shows the big data leader performance versus some of its competitors in the same industry. And again, higher profits, higher growth. This is, a fairly gross analysis. Our colleague Eric Brynjolfsson, who, we showed a video before, has done a much more fine-grained econometric analysis that controls for a number of different factors. And again, found that data-driven decision-making is statistically significantly correlated with higher productivity, higher return on equity, et cetera. So we're starting to see some evidence that this is really going to be a basis of competition going forward. Also, if you open the aperture a little bit and, look at those big deep dive domains, we're starting to see some fairly large numbers here, right? $300 billion in the U.S. healthcare economy, which could be potentially unlocked using big data. 250 billion euro in European public sector administration. And some significant increases in productivity, which are the only ways to improve living standards if, in fact, your labor force is also increasing in size. So a number of different ways in which this can provide real value going forward. And as I mentioned before, this isn't just about provider surplus. This isn't just about the service providers capturing all the benefits. So, for instance, when we look at personal location data, and we sized a pretty big number for service providers, about 100 billion, And yet, if you actually look at what the total pot of value that can be created is, there are almost 6 times as much value that can accrue to consumers. And in fact, we find that big data, much like other trends in IT, tends to accelerate the capture of surplus by consumers, which is good, on a societal benefit, from a societal benefit standpoint. And then also, I won't spend too much time here, but this, the chart is in the report again. If you look across the economy, we have, variations in the amount of value that can be created and how difficult it will be to create. If you look in the top right-hand corner, for instance, online companies, financial companies, not a surprise that there's both a lot of value available to them and they can probably capture it fairly easily because of the amount of IT spend that they have, the degree to which data is available, and the degree to which they're already a bit data-driven in their decision-making. Government, on the other hand, in the bottom right-hand corner, tremendous amount of potential value, but a lot of obstacles to capturing that value going forward. So that being said, look, that's all a happy, happy story. What, in fact, will it take to get it done? I haven't talked very much about it. I'm sure there are other people will address data policy issues, whether it's privacy, security, intellectual property. Clearly, a lot of technology and techniques, right? So if it's Hadoop or MapReduce or a number of statistical, techniques that can be used and machine learning techniques that can be used. Let me just briefly touch on 2 others. One is around organizational change and talent. This is a tremendously important one. And for this, let me hear from Jeff Hammerbacher, who's the chief scientist at Cloudera.
At Facebook, I was the first research scientist. The initial goals for my position were to understand how changes to the site were impacting user behavior. Where I tried to articulate, the infrastructure that we did build out at Facebook and the kinds of people that we were looking for in this title of data scientist. I actually see people sort of, self-describing in their job titles on LinkedIn, or I'll even go to discussions with, scientists working on like data-intensive science is a field that I'm pretty interested in, and I'll see them talking about themselves as data scientists. So it's pretty interesting. So I think it is evolving. It's taking hold. I think people do realize that there was a gap between what the title of statistician or data analyst or business analyst represented, or even data mining, and what they actually wanted. So it was kind of that combination of the whole research cycle that social scientists had, plus some additional programming skills, plus the ability to do aggressive prioritization. It was a lot of what we were looking for. And of course, we expected sort of a good grounding in statistics and machine learning. So that was kind of the table stakes. So that sort of that collection of skills was difficult to find.
So let me pick up on that. We actually believe that it will be a key constraint going forward in terms of the amount of talent that's available. These data scientists, and I think we probably have a fairly large collection of concentration of data scientists in the room today, but one that's unusual. So we did some modeling to try to understand that, because we had heard that anecdotally. It's hard to find these people. It's hard to keep them. We can't find enough of them. So data scientists, or the deep analytical talent, which is that top category that we have here, people with deep understanding of machine learning or statistics. We modeled out how many of these people are in the workforce and will be added, either through graduation or immigration, net of people who are leaving the workforce, et cetera, and compared that to, again, rough projections of how many of these people you'll need in a big data world, where truly every organization is competing on the basis of big data. In the next 7 years, we're seeing a potential gap between, current course and speed and production and need of, up to 150,000, actually 140 to 190,000 in the United States alone. Also, we'll need our general managers, our executives, our business analysts to think in a different way, to understand what sorts of experiments you need to run, to be able to challenge these deep analytical folks, the data scientists. Again, we think that there will likely be a gap of up to 1.5 million of these individuals versus positions that will be necessary in a big data world. And also, finally, the supporting technology talent. So we do think that that's a key constraint going forward, and the one that needs to be addressed. The other enabler that we actually think is very important and comes out of some of the research is, while a tremendous amount of value can be captured from data within an organization's walls, increasingly even more or multiplicative amounts of data can be created when you add data from multiple sources together. So this is an example from our deep dive into healthcare, but you have data from 4 different stakeholder groups. One is pharmaceutical and medical products. They have clinical trials data. You have clinical data from providers, hospitals, doctors' offices, et cetera. You have financial data from all the people who are payers, insurance companies, et cetera. And then an increasing nascent source of data, which is consumer data. Again, it could be things from consumer devices at home. Again, each of those can provide a tremendous amount of value using big data, but then combining them provides even more value. And some of the things that need to be overcome are some of the barriers and incentives to making sure that that data can be combined. So let me wrap with this final slide here, which are what are some of the implications for a leader of a business. The first two kind of go together, which is inventory the potential sources of data. Some of those might be within an organization, but of course those should include data which is publicly available or can be obtained from business partners and others. And in fact, another core competence that we think is important going forward is how do you create value propositions for other organizations to share data with you. I spent some time with the CEO of a major consumer products company, and he said to me, look, when I actually make commercial arrangements, I think about data as being one of those sources of gives and gets that I can, that I need, right? That I might give up some price if I can get the right data. It's that valuable to them. The second piece is, of course, understanding where that potential value could come from. And it's often an iterative process because I might think, well, I could capture that value if I could get this piece of data. So if I had this piece of data, I could use it in a different way. So 1 and 2 go together. Thirdly, building the internal capabilities. This includes talent, but it also includes changing the mindsets, changing the processes. I think everyone here is probably familiar with some of the challenges that might occur there. Fourthly, just understanding what you need to do in terms of technology. And fifthly, attacking some of these or addressing some of these data policy questions around security, privacy, and intellectual property. So with that, I think the interesting thing about it is there's just a tremendous amount of potential value here. Lots of problems to be solved, but I think a lot of the people in this room are the ones who will be best positioned to solve it. So thank you for your attention. I appreciate it, and have a great several days here.
Thanks. Let me stay. We just got a time for a short discussion while Stephen Wolfham's being set up over here. So you've been talking to a lot of obviously a lot of leaders, a lot of people who are getting it right. And we've heard it, and you brought out these implications and so on. What's kind of like the industry, the US, what's our checkup like? What's the proportion of companies you see that really get it, and how far do we have to go?
Yeah. Huge amount of variation, right? So there are a number of companies that are clearly leading, understand what they need to do. So for instance, online companies, they have this as part of their DNA, right? There are people in this room who have worked for online companies, maybe doing startups now, et cetera. This is really part of what they do. Then there are huge companies and huge parts of the economy where people are just realizing, oh, this is something that's very important. So, I think it's probably a fairly normal distribution in terms of where we are. Or if you look at the adoption curve, I think we're, just about in the early adopter stage in terms of, where we are as an economy, but a lot of individual variation amongst different organizations.
Right. It seems like, you have the implications, but figuring out the route to solve a lot of these is pretty early days yet.
Absolutely. And it varies a great deal. It's very idiosyncratic to the specific organization because, again, there's a lot of technology that goes into this, a lot of techniques, but also, at the end of the day, there's a bunch of culture, a bunch of leadership, as you mentioned, which is really vital to making this make a difference.
Mm-hmm. I think we have time for a question or two from the audience. If we bring the house lights up a little bit so I can see.
Yes, just point anywhere.
My name is Sam Whitmore. I published Media Survey. You had cited the McKinsey study in one of your slides there about healthcare. There's a $300 billion opportunity to use big data. That report stated that there's contention between the physicians who want to charge the maximum for perhaps unnecessary procedures and the payers who actually want to be able to reduce the amount of payment. So could you address the politics that will really plague a lot of these opportunities to get these savings, because each constituency might have a different agenda within an industry?
So I'll just repeat the question. So the question is, can you, often when you expose data, there's politics that come up, or you expose interests, and this seems to happen in a lot of places. Can you sort of talk about how that's going to pan out?
Sure. And embarrassingly, I'm actually a co-author of the McKinsey report. Big data does enable different stakeholders sometimes to fight for pieces of the pie. And so that applies to payers versus providers in healthcare. When you look at retailers versus CPG companies, the same kind of thing happens, right? So a CPG company could use big data in order to try to obtain pricing advantage, but then the retailers will also try to do it in order to negotiate for the best supplier contracts. So that's going to happen repeatedly, going forward. And the winner is partly going to be determined by economics, but also partly determined by their skill in using data.
Thank you.
Thank you.
Michael, thank you very much for joining us. Fantastic.
Appreciate it.